Welcome back, everyone. Today we're going to go over errors and debugging inside your code. While you're coding, a program can crash, and that would be an exception. It's called an exception in C#, where once the program crashes, it throws an exception, and the program will crash and basically completely shut down. To prevent that from happening, you can use a try-catch loop, where if you're saying like try to do this code, and if it does an exception, if it throws an exception, catch the exception and do something with it, which would prevent your code from crashing completely, and you can do whatever you want to do with that exception, such as log it or report it to the user or anything of that nature. The act of going through your code and looking for bugs is called debugging. So we're going to go over how to debug your program to find bugs, and also how you can prevent it for errors. So as this program so far that we've done, we have not written any code that has errored or could error, just because of the way I wrote it. But I'm going to introduce some errors into the code now and then demonstrate. So where we left off was we could do a whole entire battle between the giant enemy crab and the boss character. So here we have our first enemy. Now this first enemy, we create him into an enemy, and then we do stuff inside the game loop. So let's say, just for the purposes of causing an issue, let's comment out that line, and I'm going to say enemy first enemy equals null. Instead of instantiating the class into an instance of the class here in the enemy, I'm going to make it null, which is the absence of any instantiation, and basically saying this is empty right now. This first enemy is of type enemy, but nothing is inside of it. It is null. There's nothing assigned to it, and it is empty. When we go to perform the game loop, we're going to go inside here, and then it's going to say here for enemy enemy.name. Now enemy right now is null. It is nothing. Therefore, there is no .name. There is no name property to nothing. You can't just say nothing, give me your name, because it's going to be like, what? I'm nothing. I don't know what a name is. What are you talking about? If it's not instantiated, it will error. So as you can see down here, I'm blocking it a little, but right down here in the errors area, there is no error, because technically this is considered a runtime error. There is, in compile time, I have not written any incorrect code. Enemy.name, because it's of type enemy, is correct. It is not going to error here and give me an error message, because there's nothing wrong here at the moment. But if enemy is null, it will crash. Now to show that, I'm gonna run the game, and we should immediately hit an error after I name myself. So what is your name? David. And then boom, I hit an error here, and it says exception thrown on this line. So it comes here and it points, tells you this is the line 81. The exception that we got is a system.null reference exception. And it says object reference was not set to an instance of an object. So an object reference, which in this line we have an object reference of player and enemy, and it's an object reference because it is not of type, it's not a base type like int or double or anything of that. If it's a class, like then that comes up green here, it's an object. So that's why it's saying object reference. So enemy, random, player, those are object things. So here in the exception it says enemy was null. So you can see that this here enemy, in this case it told you enemy was null, and this helps you. So if we continue, we can't continue, and the program crashes because we didn't do anything with it. We got an unhandled exception. Since this is in debugging mode, this window did not close and still shows the debug information here, but it's in a real program, like if this was actually running not in debug mode, it would just crash completely. You know how like when you're using an app on your phone or a Windows thing, and then just boom, and just nothing happens, it just crashes. That's what's happened here, because we caused an error. So in order to fix that, you basically put the line that I commented out back in, instantiate it. But we're going to pretend that for some reason you weren't aware that this was set to null. So in order to do that, or in order to find out, possibly to look into errors, we're going to debug. And to debug, we hit the play, which causes starts the debugging session by default. But right now, it's just going until we hit an error, then it crashes and it tells us what's wrong. We want to kind of know what's happening before that. So here, to start the program, here at random, I'm going to put on line 11. If you go to the left here, you'll see like this gray bar. If you click in here on what line you want to put, you can put a breakpoint. Now a breakpoint is when the code's running, it's going to hit this breakpoint and stop the code and just freeze it on that line. So if I run the code now, you can see that the code is stopped and it is highlighted. The yellow shows that the line is highlighted at the breakpoint and the program has just stopped. You'll see in here, nothing's appeared because it's literally waiting for me to look at the code. Now at the top part here in the bar, can't reach my hand up, you'll see step into, step over, and step out. And what these are debugging tools to allow you to step into a function, step over a function, and then step out of a function. So in this case, I see this line here. I want to step over this function. You can see that the code goes to the next line. So now the random class is generated, and now I'm on the console right line. So with your mouse, you can put it over variables. And when you put it over variables, it'll tell you its current state. So here you can see like random is a system random, and if I hit the little arrow next here, I can see the items inside of it. But we don't really, random is not a class that we know too much about, so we're going to ignore that for now. But if we step over, you'll see player. So right now we put our mouse over player. Player is null because this line has not been run yet. If we step over now, you'll see that it gets to the point where console.readline is waiting for my input. So I put David. Now it goes to the next line here. So you can see now player exists. It's of type RPGGame.player. If I open this up, you can see that the player has health 100. I am not dead. I am not guarding, and my name is David. You can see the actual variables in the program. In this case, it allows you to verify that the code is doing what you want. So right now I'm like, yes, at this point, my player should have 100 health. He's not dead, etc. So now if all of a sudden the next line I was dead, I'd be like, why am I dead? I clearly can see I'm not dead right here. And I can kind of determine what's happening. So you can see here like player.name, and if I put my mouse over it, it's David. But if I wanted to, I could also select player, right click it, and say add to watch or add watch. And what that does is I'm going to temporarily remove my webcam. You'll see down here in the lower left, the watch, it puts the player in here and I could watch it as it transforms. So when I step through and let's say I lose health, I can see it go down. And I can kind of watch it as opposed to constantly putting my mouse over player and loading it back up. So now first enemy is null, and we're going to step through and it's defined as null, and now we're going to go to the game loop. So this is a function right here. If I was to step over, I would go to the next line here but we would error because the problem was happening inside the game loop. So I actually want to step inside of this function to continue to look inside. So that's what step into is for. So I stepped into, now I stepped into that function, and we're going to check that out. Now I'm going to step over, and here we can see this is the line that's going to error because we saw it before. So if I put my mouse over player, you can see player.name is David, and then it says enemy. Enemy is null, so enemy name is a null reference exception. It shows it right here that would be the case. So at this point we know that enemy is the problem. So you would stop your code and you would go back and you would put it in. You would instantiate enemy. Ta-da! So now the code is fixed. As I mentioned before, you can also use debugging to track when, let's say, if the health attack was being hit. So if the enemy gets hit, so let's see, let's put a breakpoint here, or at the enemy gets hit line. We're going to do a single attack Oops. So I have the breakpoint up here. I'm going to continue. So I'm going to do a single attack, and you can see the code has stopped. The enemy is going to get hit with a random attack power. So if I step into this function, you can see get hit was randomly determined to be 2. So now I should know that health equals 100 minus 2, so I should now see health equals 98. So I know this is correct. So now I can say, hey, is health less than or equal to 0? False. So I should not die. I should not be in this function. Yep. So now we can see, and now if we put our mouse over enemy and open this up, you can see now the enemy's health is 98 and he is dead. And we can just keep going through here, and I'm going to hit him attack again, and I can see, now step through, I can see the enemy is 94. I can add to watch and then hide myself again, and you can see here 94. And then if I do the attack again, right here, you can see, and once I step over, it just went to 93 because I only hit him with 1. And then I do that, and then I hit 1 again, step over, now it's 92. I'm pretty weak against this giant enemy crab. I just realized something, which I wanted to kind of point out, in the fact that I just realized I'm pretty weak. So I'm going to get rid of this right here. When I say I'm pretty weak, I realize that the max player attack power is supposed to be 20. I'm supposed to be able to hit up to 20, but the max attack power is 5, which you can see I passed into these functions by putting mouse over it. You can see here max attack power is the font color is black. Boom, I'm back. Welcome. So the max attack power is black, while the max player attack power is gray. And when a variable is here with this gray, that means it's never been used. So it turns out I actually made it and I wasn't using it. So that's a mistake. So here you can kind of see, by coloring here, I can kind of debug the code and be like, oh, I actually didn't use the variable that I made. Max attack power here has been used. So if I click on it, you'll see it highlights automatically the places where it is located. Here it's already located here. You can see it's highlighted. So if I click on max attack power here, it's only mentioned in the comment, but if I scroll down, I'm not gonna see it. So I'm gonna stop the code, and I'm gonna copy this, because when the player, when the player hits the enemy, I should be going for max attack power. So here, the enemy is gonna get hit, and it's the max player power. The enemy gets hit, it's max player power. Then I heal. And then when the player gets hit, it says max power. So now we changed it and fixed it where the player should give up to 20 damage or so. So I'm going to do a single attack again, and you can see that I hit was 9 for damage, now I did 5 damage, now I did 18 damage. So yeah, he's getting hurt a lot quicker now. So let's say you're doing something that could possibly error. You don't really want to write code that could error. You should do certain things to prevent it. For example, just saying here for this first enemy example, this is going to be just interjected here, but we could do something like, if this was being pulled from something that right here it's hard coded to be new enemy, but if it's being pulled from something else and we're not necessarily sure where it's coming from, it might not be null at the time of the code running. So if we did a check right here and said first enemy does not equal null, then we know that we can run the game loop because the first enemy is not null. If we so this way we checked via code that it is safe now to run this part, which is a good practice, and you should always be doing null reference checks is what this is called. So you always want to check for null references. And if it's an object. So hey, it's like I didn't check here because I literally defined it. It can't possibly not be there because it's hard coded to be enemy. I'm going to now delete this, and I want to do a try catch around this game, inside this game loop, to determine if any error happens, we're going to find out and do something else. So here, I'm going to set first enemy to null again, which will cause it to error. And I'm going to go inside the game loop, or I'm going to go before the game loop here. And I'm going to say, I'm going to do a try catch loop. So as I've mentioned before, if you hit try, it'll come up with a snippet, tab, tab. So now you got a try. So it says try everything inside these curly braces, try all the code inside here, and if there's any exception that is thrown, because the term is called throwing an exception. So if any exception is thrown, catch that exception and then do whatever is inside this code block, and then you could throw it again if you wanted. So if this exception here can be given a name, and then therefore I can access it. So here I'm going to try to run game loop inside of the program here, and I'm going to say if I run into an error, I could throw the exception. So I could do something and say console write line, and I could say e, which is the exception dot message. So I could write out the error, which is going to be the null reference error, to the screen, and then I could throw it again, but it would crash. And this doesn't really make sense, but in this case, like if you wanted to throw it again, you could log the error to a server, maybe, and then throw the error. So you crashed the program, but at least you knew you have reported it to yourself so you can fix it. In this case, I'm not going to be throwing the error again. I'm just going to write the error to the console. I'm going to say the program encountered an error skipping this fight. The error was, and then I'm going to say e.message. So just for the purposes of showing this, we're going to say, hey, if there's any error, I'm not going to crash your program, but I'm not going to stop you from playing the game. So you errored while trying to fight the giant enemy crab. Lucky you, you get to skip and fight the boss. Doesn't really make sense, but hey. So I'm going to put a breakpoint here to kind of show. I'm going to do it first without a breakpoint, and then I'll show you. Okay, so David. So we hit the null reference exception. Since we're in debugging mode, it kills here. We're going to go past. And so it says here, the program encountered an error skipping this fight. The error was object reference not set to an instance of an object. So now we continue the code because I did not crash at that point. So we errored on this line, which ended the code. If there was more code in the try, it would not happen. We errored here, so immediately went to catch and ran this code. It left the catch, and now we're just continuing on. So the player's not dead, so now I made the boss, and we're continuing. So David, you've encountered a big boss. What would you like to do? And I can fight big boss all the way through. So that's basically a try catch. You can put it around your code to prevent your program from crashing and do things of that nature. So I'm going to put this back here, and I'm just going to show, just for the sake of not causing the program to crash, I'm going to select every single piece of code that I have here inside of the main loop here, and I'm going to hold on my keyboard. This is a shortcut. You could either copy and paste, cut, and of the same nature to do this, but if I hit Control and then hit K and then S, Control KS, it allows me to say, what do you want to surround everything that you selected with? So I can say here an if statement, an else statement, a for loop, blah, 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 an if statement. I'm going to say do this with a try. So if I hit tab, you'll see now that everything that I selected is now inside that try catch loop. So here's the try, and then at the end of the try is the catch. So I'm going to put this E, and I'm going to say log the error to the console. And then E.message. So in this case now, when first enemy equals null, I'm not going to continue the fight, and I'm just immediately going to crash the program's not going to crash. It's going to say object reference not set to an instance of an object. So it wrote out the error to the screen, and then this is the normal thing that you get when you end. So the program did not crash, but it still told the user what's going on. It's like, hey, we can't continue the program. This is the error. You should report it. And in this case, you would typically go to the developer and hey, I entered my name as die, and I got this error. What's up? And then the guy will be like, yo, I gotta patch that shit. And then it gets real intense. So I wrote the code so far. I know it's correct. So this try catch might not necessarily help us. If I cause an error later on, this might be useful. But right now, I tend to do big try catches like this in terms of my functions, where I'm like, hey, try everything inside here. If it errors, do something with the error, because I personally don't like my code to hard crash. If you hard crash, no one's going to know why. People are going to get angry at you. If you have, like, let's say a mobile app and you encounter an error, you could, inside this catch here, you can say, pop up an alert and it says you have encountered an error. Like on an iPhone, it comes up with a little card in the middle of the screen, with the OK button. You could just come up and pop up with that error. So instead of crashing the iPhone app, you can have just, everything looks fine, and then all of a sudden this thing pops up and says like no internet connection or something of that nature. Failed to download, blah. And then the user knows, oh, it failed to download the picture I was trying to get off the internet, as opposed to just crashing and you're like, what? What happened? So I think it's a good idea to try catch errors. You don't ever want your program to hard crash, because that's never good. So thank you for watching, and next time will be the last session for the C# beginner tutorial series, where we will be going over lists and arrays, which are very similar, and the for each loop. And basically, we're going to create a history of all the attacks that the player does, and at the end of the game, we're just going to write out the history on the screen. And then we will be done with our RPG game, where you can fight the enemy crab, fight Big Boss, and save the princess in a castle. But I don't think we're not going to program the princess. Okay, till next time.